Assalamu alaikum warahmatullahi wabarakatuh. Welcome back with a new lecture with ISO 17025 2017 edition. And in resources requirements, equipments. This is a very important clause in this edition. You will find that lab shall have all equipments required to perform all lab activities and get accurate and reliable results. So all equipments should be fit for your purpose to get accurate and reliable results and should be fit for the methods selected. All equipments include instruments, software, measurement standards, reference materials like CRM or PT, reference data like all guidelines used, consumables or auxiliary apparatus and reagents. And here in 2017 edition you will find reagents, software, measurement standards, reference material or reference data. Now all of them considered as equipments, not like in 2005 edition. Different. Before that was not considered as equipments, but now considered as equipments. And instruments, as example, should be fit for your purpose. After you will select the method required to analyze specific parameters, you should select the instrument which is fit for this method. You should take in your consideration, number one, the saturation, the sensitivity of the instrument. What is the lowest concentration that can be detected by the instrument? What is the lowest concentration that can be quantified by the instrument and get accurate and reliable results? Number two, saturation point. Saturation point. What is the highest concentration that can be quantified by this instrument using this method? And you will know the range of linearity. And also you should take in consideration the uncertainty range required. Uncertainty range required to get a valid result. Accurate result within acceptable range inside using this measurement uncertainty. So all equipments used for measurement should be capable of achieving measurement accuracy and uncertainty required to get a valid result. Another point added to this edition as a note, reference material. Reference material provided from reference material producers, like FABAS as example. These reference material producers should meet the requirement of ISO 17034, and you should have a certificate by this. And also this reference material, as before also, should be provided with a certificate containing the measurement uncertainty and also metrological traceability. After that, when lab uses equipments outside its permanent control. Outside its permanent control means if the lab has a problem with the instrument that requires to analyze specific parameters, and the lab shall analyze these parameters for the customer, in this case, until the problem will be solved, the lab shall make subcontract with another lab who is able to analyze these specific parameters, but it shall ensure that requirements for this equipment or this instrument are met, such as calibration. Number one, calibration should be within accepted criteria. If there is internal calibration, should be within accepted criteria, like the slope should be within this criteria, like 0.995, or externally if required with the certificate. Also, the lab shall ensure sensitivity of the instrument. What is the lowest concentration can be detected by this instrument, and the concentration can be quantified by this instrument and get accurate and reliable results. And if this concentration fit for this method or your purpose or not. Lab shall ensure the highest concentration required to be analyzed by this instrument. So you will ensure the saturation point for this instrument. What is the point at which response is not related to the concentration? If you spike the sample with a specific concentration and you get response which is not related to this concentration, as example, this peak, you will get this peak, broad peak like this, but this area not related to the concentration required. You will ensure the working range from the lowest concentration can be quantified by this method and the highest concentration can be quantified by this method. And if this range fit for your purpose or not. Also, you will ensure, the lab shall ensure the uncertainty required to get a valid result. And here is a change, not only accurate result, but valid result. Valid result, which is the result accepted or accurate within accepted range. Within accepted range. This range, which is the result plus minus your measurement uncertainty. But before the lab use the equipment which is outside its permanent control, the lab shall ensure that all requirements required are met. The most important point for implementation of this clause, lab shall have a procedure, standard operating procedure for handling, transport, storage, use, and the planned maintenance (PM) for instruments, for equipments, to ensure proper function for these equipments and prevent contamination or deterioration. So we will prepare at the end of this lecture standard operating procedure for equipments which will be general for the whole lab. Also, the lab shall verify that equipments conform to specified requirements before use. The lab shall verify that all equipments that we mentioned before can be used to analyze the required parameters and can get accurate and reliable results. Such as instrument, as we said before, calibration and verification should be within accepted criteria, and sensitivity. The sensitivity of an instrument should be very high to get accurate and reliable results within the limit of quantitation, so it can get the lowest concentration required in the method for these parameters, and also can get the highest concentration required for this method for these parameters, and also can achieve the measurement accuracy and measurement uncertainty with a valid measurement uncertainty required with a valid result. Also, as we mentioned before, that software considered now in the new edition as an equipment and should be verified before use, such as the software with the instruments. Every instrument coming with the software. This software will be verified from the company itself. And also, if the lab prepare LIMS, as an example, LIMS, that also should be verified by the company itself. Also, measurement standards now in the new edition considered as an equipment, and they should be verified before use. You will buy the standards with the certificate from the company, provided company. This certificate including measurement uncertainty and also expiry date. Since opening date for these standards up to the expiry date, you can ensure verification. You can make verify also for these standards by you can use CRM from the calibration curve, the slope of calibration, and from spike samples. But the most important point, using CRM to ensure that these standards are accepted and can be used to get accurate and reliable results. After expiry date, you can extend the period of validity of this measurement standard also by CRM or PT. You should use only CRM or PT to verify that these standards are still accepted, are still valid, and can be used to get accurate and reliable results. Don't only depend on a spike sample or replicates, but just depend on CRM. If you get accepted results according to the certificate from CRM or PT, in this case you can still use these standards. So verification of measurement standard is very important to ensure that your results are accurate and reliable. Because measurement standard has the major effect on the result of samples. Before expiry date, you don't have any problem. You will find a certificate for these standards to ensure the validity of these standards during this period for 1 year or 2 years according to the company provider. After that, after expiry date, if you want to make extension for these standards, you will analyze CRM to ensure the validity of these standards for another 1 year. But you cannot, or you will never know if you analyze spike sample only. CRM will be more accurate to ensure the validity of these standards. From this example, you will know that if you have degraded standard, you will never know if you analyze spike sample or from your calibration curve or if you use verification standard. Because you will get result which is accepted for you, but you don't know that this standard degraded. Only from CRM, if you get result in the range that they gave you in the certificate, you will find that the result of this CRM of this compound from this to this range, if you get in this range the result, then your standards are not degraded. Your standards can be extended for another 1 year. But if you analyze spike sample using, or your samples using this standard only, you cannot decide if this standard can be extended or not. Here, if this standard degraded or not degraded, we will make comparison between them. And this equation is very important to know the sample concentration according to your standards that you prepared in the calibration curve. Sample concentration equal to area of sample divided by area of standard multiplied to standard concentration. If you run the samples and your standards, area of sample, the area for sample that you want to analyze, you get 150. 150. This area under the peak, 150. And the area of standard, we will take 10 BBB standard as example. 100 multiplied to 10 BBB, you get 15 BBB. And this is the real concentration for the sample. Here there is no degradation for the standard. The standard, 10 BBB, you can get, for 10 BBB, you will get 100, the area under the peak. This is the concentration for the standard. And under the peak, you will find area 100. So there is no degradation for this, and you get the sample concentration 15 BBB. This is the real concentration for the sample. If there is degradation happen for this standard, so the concentration, the area under the peak will decrease, as example, to 75 for 10 BBB. So it will be 150, the area for the sample, area under the peak, divided by 75 multiplied to 10 BBB, you will get 20 BBB. So the concentration for the sample will increase from 15 BBB to 20 BBB. Maybe you will reject this sample according to the maximum residual limit. So if you use degraded standard, the standard will be degraded and the concentration of the standard will be less, but the sample concentration will increase if the standard degraded. So it's very important to verify that your standard, that you will extend the period of validity for it, is still valid by analysis only CRM or PT sample. Also, as we know that reference material, such as CRM certified reference materials or PT proficiency test samples and reagents, now considered as equipment. So CRM or PT will be provided from reference material producers which meet the requirement of ISO 17034, they will provide the lab with a certificate with them. This certificate containing their measurement uncertainty and metrological traceability and validity. In case of CRM, validity for 1 year. This sample is valid for 1 year with the range of concentration from this to this. Except the result of CRM inside the certificate. Also, reagent will come to the lab with a certificate for validity and auxiliary equipment such as balance and micropipette. They will be calibrated internally inside the lab every 3 months. The balance will be calibrated by calibrated weight every 3 months to ensure the accuracy of this balance. And also micropipette also will be internally calibrated every 3 months. And every 1 year, they will be calibrated externally in calibration lab to ensure the validity of balance of these auxiliary equipments to be used for another 1 year. So there is internal and external calibration. So all equipments, as mentioned in ISO 17025-2017, should be verified before use because they will affect on the final result. Another point, but explained before many times, equipment used for measurement shall be capable of achieving measurement accuracy and uncertainty required to provide a valid result. And valid result, as we said, this is a new expression now, not accurate, not only accurate result. The difference between accuracy and validity of results: accuracy, closeness of results to the true value, but validity of results, accurate results also, but within acceptable range. Because measurement uncertainty now shall be in the report. So, in this range, your results are valid. You will ensure that in this range of concentrations, your results should be valid. And that will be also again explained in another point, another clause of this ISO. Example for this: if you want to analyze compounds such as chloramphenicol, veterinary drug in food of animal origin, which has minimum performance required level determined by European guidelines, which is 0.3 ppb. 0.3 ppb. This minimum performance required level, such as like maximum residual limit for other compounds. So this is the maximum you can get for this compound. Higher than this concentration in any sample, the sample will be rejected. So you should have the instrument which is capable, and method also, which is capable of achieving this concentration or even lower than this concentration. So you should have the instrument which is capable of achieving measurement accuracy and also uncertainty required to provide a valid result. Another point added to this edition: conditions to calibrate the equipments such as balance, such as micropipette, thermometer, all equipments that can affect on the validity of results, they shall be calibrated, shall be calibrated, recalibrated again if accuracy or measurement uncertainty of these equipments affect the validity of results, and or if required to establish metrological traceability of results, reported results. And metrological traceability, you will find, if you go back to lecture before, there is one lecture for metrological traceability. Another very important point: to organize the work inside the lab for all equipments and prevent any confusion for calibration of these equipments, lab shall establish calibration program for all equipments inside the lab, such as for auxiliary equipments, as we said before, for balance, as example, will be calibrated every 3 months by calibrated weights. And these calibrated weights also will be calibrated every 1 year from calibration lab. Balance will be calibrated externally, so internally and externally. Externally by calibration lab to ensure the validity of results from this balance. And also micropipette will be calibrated internally every 3 months and externally every 1 year to ensure the accuracy of these micropipettes. And thermometer, everything, water bath, every equipment inside the lab should be calibrated, should have a calibration program. Your instrument, if you are working with LC-MS, in this case you want to calibrate daily, and if you will calibrate every 3 months, as example for HPLC, in this case you should make verification for this calibration, for this verification every working day. So you should have calibration program with forms also. You should have forms for this calibration verification form to record all data for calibration and verification for all equipments inside your lab. You should also label equipments that need calibration within a period. You should have a label specific for calibration for these equipments, that this equipment should be calibrated in this period. So that will prevent any confusion for any analyst inside the lab. And label out of service equipments. If there is any equipments outside the service, out of service, this equipment should has a label, specific label, that this equipment out of service until you will finish the maintenance of this equipment, until it has been verified. In this case, you should have maintenance form, plus this label, and after you will maintain the equipment, you should verify that you should make calibration for this equipment and also verification. And this result for calibration for this equipment also should be provided, attached to the maintenance form, and this result also will be recorded in calibration and verification record form. So out of service equipments shall be labeled, and during this period nobody can use this equipment. It should be isolated, nobody can use, and deviation from specified requirements will be studied well, such as LOQ, measurement uncertainty, accuracy, before verification of this equipment. So equipments that are not conforming to its own procedures or customer requirement or international guidelines, lab shall examine the effect of deviation on the result from specified requirements, and shall initiate the management of non-conformity. If these equipment will be non-conforming to the specified requirement or customer requirement or international guidelines or the method itself, so this equipment will affect on the validity of results, and the lab shall initiate the management for non-conformity work procedures, and that will be explained in details in the process requirement in clause 710. Also, we should have a regular check for the equipment, to maintain confidence in the equipment performance. To ensure the equipment performance, you should have intermittent checks. As example, for your instrument, you will run calibration standard. After some samples, you can select 5 samples at the beginning. You can run verification standard. Verification standard to verify the calibration, and also to ensure that there is no contamination in the instrument. If there is any contamination, cross-contamination from the instrument, as example from the column, that will be transferred to all results. So you will know from the verification standard. If you get verification standard higher than the normal, higher than the real concentration, in this case, if you find any positive sample after that verification standard, you will repeat this positive sample again. So you should have a regular check, such as verification standard. In between your sequence, if you have long sequence, you can make after 10 samples, as example, you can make up to 10 samples, and then you add verification standard to verify your calibration, and also to ensure that there is no cross-contamination from the instrument that will affect on the sample results. Another point also related to the previous point, When calibration or reference material data include the reference values or correction factors, the lab shall ensure that the reference values and the correction factor are updated and implemented to meet the specific requirement. As we said in the previous point, if you did calibration standard, if you run calibration standard for your instrument, and after 10 samples as example, you add verification standard to ensure or verify this calibration. If there is any cross-contamination in the instrument, the verification standard concentration will be higher than the real concentration. So if you get any positive sample after this verification standard, you should repeat all positive sample again. So this correction factor will be updated and implemented to all the sequence to ensure that you meet the specific requirements. You will repeat all positive sample after this verification standard. This is as example only. You should have some measures to prevent unintended adjustment of equipment from invalidating results. These measures, very important point because related to risk-based approach, which is the most important point added to this edition, risk-based approach. You will have some measures to control your work, to prevent or to avoid any risk coming from your equipments, to prevent any unintended adjustment for all equipments, as we said before. As example, the instrument. You shall ensure the performance of your instrument every working day. Before running the sequence, you shall ensure that your instrument is stable and is performing well. You will run the instrument with mobile phase for some time until your instrument will be stabilized, and then you will run the reagent blank. If there is any contamination, you will know from that reagent blank, and that contamination will be removed from other samples. And then you will run calibration standards. You will run calibration standards, and this calibration standard should have slope more than 0.995 slope of calibration curve, so it will be accepted. So there are some criteria here also. After some samples, as example 10 samples as we said before, you will run verification standard to verify your calibration standard and also to ensure that there is no cross-contamination from the instrument. Then you have also PM, maintenance for the equipment for your instrument, as example 2 times per year. Also in case of LCM SMS, you have tuning, you have check tune and auto tune for your instrument. You will tune the instrument, your mass, to ensure that your mass is working well in this range of molecular weights. Also, your standards, measurement standards, also these are equipments, should be verified. You will verify these standards using another standard from another company to verify, as example, to verify your measurement standard. Also, auxiliary equipment such as balance should be calibrated every working day by your range of concentration, range of weights you need, by calibrated weights. Many examples for this point. You should have some measures, and you know that in your lab, some measures to prevent any unintended adjustment of equipment from invalidating results. These measures, risk-based approach, depend on the risk that you had inside the lab. If you had any risk, you will find measures to remove this risk. And don't forget that all records for equipment shall be retained. For an instrument, you shall have logbook for every instrument inside the lab, including equipment record form. In this form, you will write all parts of the equipment from receiving, so it will be with receiving date. And if you have new part after maintenance, as example, if you change any part, you will write also this part, you record this part in equipment record form. You will have authorization sheet. In authorization sheet, you will write the authorized personnel for this equipment, for this instrument. Maintenance form, if you have any problem happen to the instrument and you fix it already, you will have what happened exactly from that problem happened, and then what you did to fix this problem inside this form. With attached also, you will attach the calibration curve after you finish this form, and to perform that your equipment now is performing well. Calibration and verification record form, you will record all calibration. If you run calibration daily, you will write in this form that you run calibration daily and the acceptance criteria for that calibration, slope of calibration curve. If you run verification and calibration after 3 months as example, and verification standard daily, you will run that. You verify your calibration and the recording is performing well. The equipment is performing well with the acceptance criteria. By verification standard will be plus minus 10% for standards. Performance, the performance of the equipment, and you will check the performance of your instrument daily before every working day to ensure that your equipment or your instrument is performing well. Also in your lab you will find many auxiliary equipments such as balance, micropipette, freezer or fridge, water bath, many auxiliary equipments, and you can know what are the records shall be retained for these equipments. As example, for balance you will have performance of this balance. In this performance you will write the calibration records for your balance calibration every working day to ensure the acceptance of this calibration, the acceptance of, and to ensure the performance of the equipment. And also you will ensure that the balance is clean or not. Whatever points you will add in this form for performance of balance. And also you will have external calibration certificate every 1 year. Certificate you should keep also. And for micropipette as example, also you will make internal calibration every 3 months as example. So you should have a record for that with acceptance criteria to ensure the accuracy of this equipment of micropipette. Freezer or fridge, you have thermometer or data logger to check the temperature of freezer or fridge is performing well or not, and you will record in temperature recording form. Water bath as example, also another example for using thermometer or data logger to ensure that this equipment is performing well and giving you the right temperature, and you will record that in temperature recording form. If you have any other auxiliary equipment, you also shall retain all records for this equipment. For measurement standards also you should have some forms such as stock standard preparation form. In this form you will write how did you prepare your stock standard from even powder or liquid, whatever the standard you received from the company, and you should have a certificate for the standard you received from the company. Then you will also have intermediate standard preparation form that you prepared from the stock. Then you will have spike standard preparation form and how did you prepare that spike, and expiry date for all of them should be written in this form also. Calibration standard preparation form also should be recorded. All calibration that you prepare even daily or after 3 months, you should record your calibration, and also you should have always the expiry date for these standards should be recorded in these forms. For reference materials such as CRM, Certified Reference Material, or PT, Proficiency Test Sample, you will have a PT file including certificate from the company provided also, as example FABAS, and this company should be accredited according to ISO 17034 with the accepted result or assigned value from this company. You will have the assigned value certificate containing the assigned value for this sample, and your results also acceptance results your results should be in the range of their acceptance, in the range of their assigned value. In this case, you shall have at least one PT every year for every method, not every compound. Because sometimes you have many compounds, you have 100, 200 compounds for one method. In this case, you cannot get all of these compounds, so you should have at least one PT for every method. You can increase as you like, but you shall have at least one PT every year, accepted according to their assigned value every year. One PT every year. Reference data, all guidelines, all reference used to prepare your method or to validate your method, you should keep in file which is manual. In this manual file, you will keep all guidelines used that was written in your SOP. Also for reagents, all reagents, you will have a list of chemicals. When you receive the reagent inside your lab, you write that you receive in this date, and there is expired. This reagent will be expired after this time, after this duration time, and also you will have mobile phase preparation form. Whenever you prepare your mobile phase, you will write that you prepare from which composition and when that mobile phase will be expired. And also any solvent you will prepare inside your lab, you shall have a record for this prepared solvent by how did you prepare, when you prepared, and also expiry date for this solvent. All equipments inside your lab shall be labeled. Don't forget this point. Shall be labeled to prevent any confusion. That was my suggestion on how to implement that clause in the new edition in your lab. And also another very important point you should take care for, which is software. Because this is new point added to this edition. Software now is considered as equipment and should be validated. When the lab use any software developed by the lab or by external provider, this software shall be validated. And this validation shall demonstrate that this software is fit for purpose. Actually, inside the lab, most or all software used inside the lab are built in the equipment. So built in the equipment from the external provider shall be validated with a certificate, and you should accept this instrument or this equipment by this validation for software. So validation shall be included in the acceptance test and also considered during calibration. Also, you should have general SOP for equipments that will be for all the lab. Purpose of this SOP to ensure that all equipment inside the lab meet the specific requirements, verified and well maintained. Scope of this SOP applied to all equipment inside the lab, including as per in the new edition, including instruments, reagents, measurement standards, reference material, reference data, software, and also auxiliary equipments. Procedure for this SOP: equipments shall meet the specific requirements for the method and parameters you will analyze. After you will select the method, based on this selection, you will find the best instrument can be used for this method to analyze these parameters, and that will be under responsibility of technical lead and also authorized analyst for this method. They will say this instrument, they will decide which instrument required for this method to analyze these parameters according to sensitivity or accuracy. After acceptance of the instrument, the analyst shall ensure that received equipments are performing well and also have all acceptance data. He will accept the technical lead and the authorized analyst. They will accept this instrument from the company provided, and they will have the acceptance data for this instrument or equipments and what are the certificates required also. Then analyst also shall prepare a logbook for equipments to record the history for these equipments from receiving date. Analyst also shall label all equipments with a specific label, and this label shall have all information about this equipment from receiving date also up to, like for the standards, up to the expiry date. And maintenance shall be also maintained here in the SOP. What are your process for maintenance for these equipments? And you shall have records for all of these equipments inside your lab. Many other points also can be added to this SOP according to your work related to the purchasing of equipments, maintenance, calibration, maintenance plan, calibration and verification. That was the end of our lecture for today. Inshallah, after that we will discuss the process requirements Don't forget to subscribe my channel and share all information with your friends. Thank you and see you in the next lecture inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.